All right, hello everybody. Today you're going to be looking at solving two-step inequalities. Two-step inequalities. Now, a lot of the same skills that are used in solving equations are going to be used in solving our inequalities. You can see that you have a new IXL skill that's going to be assigned there. And you actually don't have a link for Nearpod. This is just from my other one. All right, so by the end of the day, you'll be able to find the solution set for two-step inequalities. Yesterday, we looked at how we can graph that solution set. Today, we're going to be solving inequalities and figuring out what that solution set is. Okay, you will accomplish this by isolating the variable and graphing the solution set. So here's our first example here. And our goal is the same as with equations. We're going to isolate the variable, right? This looks exactly the same, except for instead of an equal sign, we have an inequality here. So this is 7 plus 4 times w is greater than -5. Okay, and just like we do with equations, I'm going to make kind of this barrier here, this wall, to keep the left side of our inequality separated from the right side of our inequality. So we've read this 7 plus 4 times w is greater than -5. Great. Let's identify the variable. The variable is right here. Now remember, it's important to identify where the variable is because that side of the equation is going to tell us what to do. It's going to dictate to us what our next step is. Because our first goal is to get that variable term on its own. So we need to get rid of that +7. To get rid of a +7, we're going to add a -7. Okay, we're adding a -7. And remember, if we add -7 to one side, we must add -7 to the other side over here. The reason why we are adding -7 is because that creates a 0. 7 plus -7, a +7 plus a -7 is 0. Plus 4 times w is greater than, and on the right side here, we have -5 plus 7 negatives. Remember, take time with this. When we're adding negatives plus negatives, that is 5 negatives, plus 7 negatives. Negatives and negatives all like each other. They're not going to take each other out, so we end up with just a bigger pile of negatives. We end up with 12 negatives. Now 0 plus 4w is 4w. So 4w is greater than -12. So we created a 0 pairs with that +7. And now we need to undo this operation by doing the opposite. So what operation is going on here? This is 4 times w, remember. So to undo 4 times w, we're going to divide by 4. We're going to divide by that coefficient. And if we divide the left side by 4, we're going to divide the right side by 4 as well. The reason why we're dividing the right side by 4 is because that creates a 1w. 4 divided by 4 is 1. W is greater than. Negative divided by a positive is a negative, and 12 divided by 4 is -3. So there we have our solution set is w is greater than -3. Today we're just going to look at solving these as we just looked at here, and then tomorrow you'll look at solving them as well as graphing these on a number line. Let's have you guys try one of these. Again, feel free to pause these videos at any time to take these notes or rewind them to go back and look at a problem. So go ahead and try this problem. Now, if you did this problem correctly, now 4 plus 2 times k is less than or equal to 8. Okay, I read it, rewrote it. Identify the variable. Let me separate things here. Okay, our variable is right here. So we're first going to isolate that term with the variable, which means we need to get rid of that 4. So we're going to add -4 to both sides. That creates a 0, right? This 4 plus -4 makes a 0. They wipe each other out. So we're left with just 2 times k on the left side. 2 times k is less than or equal to, and now we have 8 positives. 1, 2, 3, 4, 5, 6, 7, 8 positives. Adding 4 negatives to that. 1, 2, 3, 4. Every time a positive and negative get together, they take each other out. They don't like each other, and we're left with 4 positives. What do we have more of? We have more positives. How many more positives do we have? We have 4 more positives. Okay, we took out the 4 positives by creating 0 pairs, and now let's undo this operation. Remember, this is 2 times k, so to undo multiplication, you're going to divide by 2. So we get 1k is less than or equal to 2. K is less than or equal to 2. 2. There you go. Let's see what we got next here. This one is only slightly different because we're dealing with the variable is getting divided by a 2. Okay, so let's go ahead and look at this one here. We have w divided by 2 minus 16 is greater than -17. So first thing I'm going to do here is go through and add the opposite. Anytime I see subtraction, I want to add the opposite. Okay, so this is w divided by 2 plus -16 is greater than -17. Identify the variable. Well, our variable is right there on the left side. It's getting divided by the 2 there. So the first thing we're going to want to do is create 0 pairs with the -16. Remember, it's important to identify the variable so we know what side of the equation we care about looking at. The side of the equation, or in this case, the inequality with the variable, is going to dictate to us what to do here. So we need to get rid of this -16. To get rid of -16, we're going to add +16. If we add +16 on the left side, we're going to add +16 to the right side, and we see that we end up with w divided by 2 is greater than, what do we have more of? We have more positives. How many more positives? 1 more positive. In order to undo now this operation of division, to undo division, we're going to use multiplication. Okay, so we need to use multiplication to undo that division there. So I'm going to multiply by 2. Multiply both sides by 2. I multiply this side by 2 because this 2 times w is 2w. 1 times 2 is 2. And right there we see that we have the 2 divided by 2. That creates a 1w. And on this side, we have 1 times 2 is 2. So in the end here, this creates a 1w, and 1w is greater than 2. All right, let me clear that out. And now your guys' turn to try this one on for size. And here we go. Y divided by 3 minus 13 is less than -12. Remember to rewrite this so that we are adding the opposite. That's a -13, not a +13. Okay? There's the variable term. We need to get rid of that -13. To get rid of -13, we're going to add 13 positives. If we add 13 positives to the left side to get rid of that, we're going to add 13 positives to the right side. Whatever we do to one side, we got to do to the other. That makes 0. They take each other out. That's why we add +13 to get rid of that darn -13. And now we have y divided by 3 is less than. And now let's do some math here. We have 12 negatives plus 13 positives. We have more positives than negatives. How many more? 1 more. So we created 0 pairs with that -13. Now we need to undo this operation here. We need to undo y divided by 3. How do we undo dividing by 3? Well, we're going to use multiplication. We're going to multiply by 3. Multiply by 3. Once again, 3 times y is 3y. 1 times 3 is 3. And there we get that 1, right? That creates a 1y. Any number divided by itself is 1. And 1 times 3 is 3. So once again, we end up with y is less than 3. All right. Now, so far, everything's been pretty much the same as solving equations. There is one twist to things here, okay? So let's go through this thought exercise here, this thought experiment of looking at a couple things here. When we're multiplying and dividing both sides of an inequality by a negative, what's going to happen? So first of all, do you agree that 4 is greater than 2? Hopefully you do. Okay, 4 is greater than 2. Okay, so let's see what happens when we add a positive 2 to both sides. Okay, so I'm going to take 4 and I'm going to add 2 to that side, and I'm going to add 2 to the right side. Now, when we add 2 to this side, is this inequality going to stay true? Is the inequality still true? Well, let's find out. 4 plus 2 is 6, and 2 plus 2 is 4. And sure enough, look at that. 6 is greater than 4. It still holds true when we add a positive 2 to both sides. How about a negative 2? Will this inequality hold true if we add a negative 2 to both sides? Let's find out. Okay, so is that still true when we add negative 2 to both sides? Let's see. 4 plus negative 2, that is a positive 2. And 2 plus negative 2, that is 0. And sure enough there, 2 is greater than 0. 2 is still greater than 0. It does check out. It works. So when we add positive 2 or negative 2 to an inequality, when we're solving it, our inequality symbol is going to stay the same. We're not messing with anything. The inequality is still true. Things are still hunky-dory. We're still feeling good about ourselves. Let's go on to another situation, though. What about multiplying by 2 on both sides or multiplying by negative 2? Okay, let's go ahead and check that out. So if we were to multiply both sides by 2, let's see what happens. Okay, we have 4 times 2. Is that still greater than 2 times 2? Well, 4 times 2 is 8. And 2 times 2 is 4. And look at that. 8 is greater than 4. That works out. We can multiply both sides by 2 and get a true inequality. Next, let's take a look at multiplying both sides by negative 2. So here's 4 times negative 2. Is that greater than? Is this inequality still telling the truth? If we multiply both sides by negative 2, let's find out. Okay, 4 times negative 2 is negative 8. And 2 times negative 2 is negative 4. Uh-oh. Negative 8 is not greater than negative 4. Our inequality is no longer true. What happened? Why is this the case? Let's go ahead and take a look at a more basic approach to this, a more basic problem. Let's see here. Just make a number line over here so we can visually see what's going on here. So here is 0, okay? And we'll put 1 right here, and then there's 2, and there's 3. Okay, and we're going to look at 2 values here. We're going to look at 1, we'll call that point A, and we'll look at 3, we'll call that point B. Okay, now I'm sure you would all agree with me that that 1 is less than 3, right? We can see on the number line, 1 is less than 3. 1 is further to the left on the number line than 3 is. Okay, now when we multiply both these sides by a negative 1, okay, I'm going to multiply this side times negative 1. and I'm going to multiply this side times -1, what happens to these values on the number line? Well, 1 times -1 is -1, and 3 times -1 is -3. So we see that they stay the same distance from 0. Right? -3 is still 3 units from 0. Call it b prime sub 1. And a is still 1 unit from 0. But now look, which one is larger? Well, a is larger. A is greater than b. -1 is greater than -3. Okay, because when we multiply something by a negative, it is kind of mirrored over this 0, right? 0 kind of acts as a mirror. So those points that are closer to 0 remain closer to 0. Those points that were further from 0 get further from 0. So when we multiply by a negative, or you'll see when we divide by a negative, this happens. We have to flip our inequality. Okay? So our rule for multiplying or dividing by a negative on both sides of an inequality. When we multiply or divide both sides of an inequality by a negative, okay? When we multiply by a negative, we must flip the inequality symbol to keep the inequality true. Okay, here's an example, a little one-step inequality here that we're going to have to solve. Let's go ahead and see here. We have 4 is greater than -2x. So again, we don't have anything to get rid of. Our variable term's already on its own. So we just need to undo this operation here. Make some wall here. We're going to divide by that coefficient. And we're dividing by a -2. Alarm bells need to be going off when you're dividing or multiplying by a -2. Multiplying, dividing by a -2. Dividing by a -2. Dividing by a -2. And that tells you that we need to flip this inequality symbol. Okay? You've got to flip this when you multiply or divide by a -2. Okay? It's just something you gotta kind of memorize and know to do that. Same thing's gonna happen here. You're gonna multiply both sides by a -4, and you're gonna have to flip this inequality symbol. All right, go ahead and practice this problem here. All right. Again, I see that my coefficient is -3, so already I know that at some point I'm going to divide by a negative there, and at some point I'm going to have to flip my inequality sign. Okay, this is -3 times x is less than 12. All right. I'm going to divide by that coefficient, because -3 divided by -3 is going to create a 1x. Okay, and I'm going to divide this side by a -3. 12 divided by a -3, a positive divided by a negative is a negative, and 12 divided by 3 is 4. Okay, so now though, remember, since I divided by a -3, divide by a negative, then I need to flip this inequality symbol. So it goes the other way. Then flip inequality. So we end up with x is greater than -4. All right. That's all we're going to go through today. I'll get you guys started here. There's just more examples. But you guys on IXL are going to work on T8. I'm sorry. No, you're going to work on T7. T7. T8 is for tomorrow. T7 is for today. T7 in There you go. Enjoy.